Could you please explain potentiometric?
So the potentiometric surface. So as you can see down here, you have basically a drawdown with your recharge area, and then this is your land surface, which would be here, and your potentiometric surface drops. Basically, it's a pressure type of situation where you can see that the aquifer B, due to the recharge rate, is going to, you're going to have increased pressure to the surface here, and this is basically a line that is showing basically where the head might be on the vertical flow gradient.
So didn't the velocity increase on the tide change?
On the tide change, I'll show you that one too. So the velocity, what happens here is when you get into, you can see velocity in the blue. So if we're looking at a speed here is approximately 200 micrometers per second. So what you have here, it looks like you have a slight decrease and a slight increase. It goes back down, and then as the tide stabilizes, like as I mentioned, you have a swirling where the water is not going to be going in any particular direction. So you could get a wide variety of direction, you know, and your speed indicators could scatter also. Then as the tide moves back out, it looks as it starts faster and then it moves out slowly. Now where we live here in Florida, we typically will have 2 to 4 tides a day. So in the morning, you know, you may have a tide that comes up and then it'll go down a bit, and then you'll have a higher tide, and then the next day it'll fall down. And it'll be similar, but it'll be a little bit different. And then depending on the wintertime, we have extreme low tides and high tides. Yeah, it was just kind of a general overview I was giving as the tide coming in, but you're going to have your speed changes based on the different types of tides that you're seeing.
And what depths will the borescope operate at?
From 0 to 1,000 feet.
Can it measure vertical movement of water in a borehole?
It can, but the way that it's set up is it's set up to measure the horizontal movement. So anything that is moving vertically within the well is going to be an outlier, and that's not going to be picked up because you're going to have an alpha and a beta point. So it's going to be picking up the horizontal movement.
Does it work in steel bores?
In steel bores, it's suggested that you would use a grounding cable, so it will, but the instrument should be grounded to remove any of the potential interference that might be caused by that.
And how long will the equipment have to remain inside the well before we have good results?
It depends on the well. So if you have a good well with preferential flow, like for example, if I put it in this bucket and I spin the bucket, you're going to start seeing linearity within a few minutes. But what you want to be careful of is when you drop the probe down into the well, you just want to be careful that you want to lower it down as easily as you possibly can, not to cause any disturbance or any type of, you know, it depends on what's in the aquifer as well. Is it a rock formation? Is there going to be any type of wave action or vibration? So as quickly as you can have, if you're below the static water level far enough, you're not going to have any changes. And if you're in a preferential flow zone, it's going to pick it up within minutes.
Sorry, I presume the borescope works best in purged wells?
Yeah, because there is there can be an issue if you have it in a well that is not well purged, that you're not getting a good flow in from the exterior of the aquifer.
How long do you have to leave the instrument in a well after insertion before you get good data? For example, if you had a bore with 10 metres of screen and you wanted to access flow every 1 metre, how long would your survey take?
Again, it was similar to the question before about depending on the aquifer, but yeah, within a matter of minutes, within a good section, within a well-purged section of the screen.
Does the probe need to be stationary to take measurements, and what rate can it be lowered?
What we try to do is we try to identify where is the static water level, and then just to lower it down as slowly as we can, not to disturb the well, and then depending on the area of the screen that you're trying to measure, if it's a 10-foot screen, you may want to take a measurement or look for that layer maybe every half of a foot. So it's just each situation it can be different, but again, you want to put it gently down into the well so not to disturb it, and then because obviously the quicker you put it down, the more you disturb the well and any type of impact that might cause. it's going to affect your reading. Now, if you're in a well that has a higher flow, obviously it's not going to have the same effect in a well that may be moving centimeters per day versus something that is moving feet per day.
What limitations are there for the use on contaminated sites, especially when NAPL present?
That could very well cause some issues. I mean, a lot of the questions, I mean, not so much with the screen. The screens are sapphire. It's very easy to contaminate, but more so from the standpoint of, you know, protection. It's just the same type of protection procedures that you want to go through when using something like a bladder pump or a groundwater pump. It's 300 series stainless, and the cable's Kevlar, so it's about as durable as it can be. It's just a matter of being safe for yourself and using the proper protection, and then properly contaminating.
I can answer the next one. Yes, the software does come with the instrument. On the title plot, where the speed scatter is seen on the title plot, would you not expect the speed scatter to trend slower rather than faster?
It really, when you're in a situation where you have a change in it, the data tends to scatter when you don't have preferential flow. So yeah, that's not surprising, just in some of the evaluations of some of the wells that we've done on that particular with this particular instrument. It's not surprising to me. What I'm more concerned about is, so if you see that you have basically an hour's time between here, which is probably, you know, here you're probably going to have slack tide. That's probably about right. I'm just more concerned about seeing the speed pick back up and then lineate to show a consistent reading, which would be consistent with the tide.
How well does the instrument work in a backfilled bore where the backfill might disturb the signal of preferential flow zones and faults?
If it's going to interfere with the preferential flow zone, similar to what you see on the tidal influence, it's going to show like we call it a reading of swirling, where you're not getting consistent direction or you're not getting a consistent velocity. So I would say that would not be a good application for that.
Is there any concerns with aquifers that are high in salinity?
Like I said, we've used it in seawater, and it's constructed out of material that should be safe for use in that. So seawater should be.
Is the equipment intrinsically safe?
I believe it is intrinsically safe. And also, like I mentioned before, if you're using it in a stainless steel or not in a steel well casing, that you can ground that. So
can the instrument be used in both an open and closed well?
I mean, I guess if you took the fittings off, you know, potentially, I mean, it could be done, I'm sure, but typically the well is open.
How do you ensure the direction/orientation of the borescope?
You can go in and you can do, it has, like I said, it has a gyroscope that's basically set up into the instrument, but you can go into the software and you can do a manual correction.
How long can the equipment log for?
You know, obviously if you're running it off of a battery, it's going to be as long as the battery will last that you're running it off of your car. But I think it can log continuously as long as you have power to the instrument. It's going to continue to charge. I've been running it for 3 days.
What hardware is required at the wellhead for data recovery?
You need a laptop, and depending on if you're running it off of, yeah, so you would need your batteries. Basically, you have a controller. So you have a controller, a laptop, the instrument itself, and then you would have a reel that would have as much cable on it as you have with the instrument. So I think I have a 300-foot reel that this is on under the table right now. So basically, you know, anywhere from 100 to 1,000 feet of Kevlar cable.
How do you stop the device from rotating when in the bore? Is this an issue?
It's not an issue because it has basically it's like a gyroscope. So any way that you turn it, you're going to get your magnetic north. So it'll be fine. Yeah. It's designed to work that way.
How does the instrument handle two-phase flow, i.e. petrol on top of the water table?
It's just a matter of if it's able to pick up particles in that. I mean, obviously you're not going to be reading the petrol, but it will, once you get it down through that layer, it'll start picking up the particles again on the once you get into the water table. As I mentioned, the lenses are sapphire, so if you decontaminate them, they will clear as you drop them through. As long as it's not anything that's, you know, like a tar or anything like that, you should be okay.
Does the software include adjustment for porosity and velocity calculations?
Yeah, it contains let me just give you an idea of some of the different configurations. So some of the things that you can identify your well, the depth, the date, and the magnetic declination on that. You can configure the tracking on this for particle sensitivity, minimum particle size, maximum velocity, and a minimum number of particle matches. So that way you can dial in specific to your application, as well as using the LED brightness. And then, as I mentioned, that's kind of what in this area allows you to tighten down your range of focus on this instrument.
How do you distinguish between a swirling bore and a bore that has flow interference?
It's difficult to do because you're going to get similar reading.
What's the minimum casing diameter?
The minimum casing diameter, I believe this is 1.75 inches diameter. So typically is what we say is a 2-inch well, is what the minimum well size we could use that in.
Is the laptop required in the field, or can the data be downloaded back at the office?
Well, the laptop is required in the field, but you can download the data anywhere you would like to, but you do have to have the laptop in the field with you. So it's basically the controller.
Where is the data logger kept? In the probe?
It's kept in the software.
How much does it weigh?
The probe weighs approximately 5 pounds.
Is there an influence on readings for non-horizontal flow? I.e., if particles are moving across the field of view at 45 degrees, can the borescope detect the flow is not horizontal and compensate accordingly?
It's going to pick up the particles in a horizontal plane because, as I mentioned, depending on how closely you crop the area of focus on it, it's gonna read within that area.
Does the
That's okay. So it's going to track particles based on how you set it. So if there's a vertical, it'll pick it up, but you can create the settings to tighten or lower particles moving within that gradient.
Does the equipment detect the depth at which it's deployed?
It does not at this point. And I don't know if you can see on this particular one right now, the cable is marked at 1. So this is from the field of view to 1 right here. If you can see, so that would be a 1 meter mark.
Are there any limitations or preferences in terms of bore diameter?
As far as bore diameter, I think the key there is to make sure that the bore, especially the screened area, is well purged. So diameter is not going to have as much of an effect on it as inaccurate readings from or from a well that's not moving because it's not properly purged.
Will the oil you pass through not affect the particle flow in the water column below?
If it's if it's on the surface, it shouldn't affect the groundwater below it. No, but if it's if the oil's mixed in if it's dissolved phase, yeah, it definitely could have an effect on it. Still, you're gonna pick up your readings of the particles.
What maintenance is required, and calibration, frequency, and where can it be done?
The instrument does not need to be calibrated. As the maintenance, it's an LED lamp in here, so the life of the lamp is very long. Obviously it's dependent on frequency and length of use, but the lamp should last years, and it's because it's made out of 300 stainless and Kevlar. It's very easy to decontaminate.
Is it designed to be deployed using just using the attached cable? Is this strong enough?
It is. It's Kevlar jacketed, so it's got a tensile strength long enough to drop this instrument to 1,000 feet.
Is there any preference or limitations for slot height?
Just a standard screen that would be used. That's typically what we're using with them. I wouldn't say there's any preference.
Yeah.
Just your standard monitoring wells.
So you said purge the well before testing. Is this really an issue?
No, you don't have to purge the well before testing. You want to make sure it's a well that has been purged and doesn't have any buildup on the side of the screen.
Yeah.
So you want a well-used environmental well. So if it hasn't been purged in a while, it might be a good idea to do so. But if you're using it for regular groundwater sampling, it should be okay. Thanks,
Rob. Well, I think that's the end of all the questions. I'd especially like to thank you, Rob, for your time today. Thanks very much.
Thank you.